lots of movies, but this is the best one yet.
We agree.
Now, keep your eyes peeled for my Hitchcockian style cameo. You're about to get the thrill ride of your life.
Project, we had to solve the problem of locating the first 4 opportunities that Luke Skywalker would have when shooting at Darth Vader for the upcoming Star Wars film, The Empire Strikes Back. We used the equation for Luke Skywalker's flight plan, f of t equals -1 minus cosine squared of t over 4 pi plus 2 sine of t over 4 pi, in order to solve for the first 4 times when Luke, after time t equals 0, would shoot at Darth Vader. Using a Pythagorean identity, we replaced cosine squared of t over 4 pi with 1 minus sine squared t over 4 pi. We simplified the equation to f of t equals sine squared of u plus 2 sine of u minus 2, replacing t over 4 pi with u. We solved for the answers of the equation using the quadratic formula. The resulting answers were u equals -1 plus or minus the square root of 3. We took these answers and plugged them into the equation sine of t over 4 pi equals -1 plus or minus the square root of 3. The equation sine t over 4 pi equals -1 minus the square root of 3 is impossible because -1 minus the square root of 3 is equal to -2.732. This answer does not work because sine values cannot be less than -1 or greater than 1 because of the amplitude of a sine function. We then took the only other possible answer, u equals -1 plus the square root of 3, or approximately 0.732, and use the inverse sine function to find at what time Luke would be at the appropriate height to shoot Darth Vader. However, after taking the inverse sine of both sides, we were only left with the sine value for t over 4 pi, and had to multiply both sides by 4 pi in order to find Luke's actual height. This gave us a value of approximately 10.32 seconds. We solved for the period by using the period formula, period equals 2 pi over b, where b equals 1 over 4 pi. This resulted in a period of 8 pi squared. To find another solution, we took the first solution of 10.32 and added on the period 8 pi squared to get our other answer of 89.28 seconds. To find the last two solutions, we first found the supplement of 0.821, the original signed value of t over 4 pi, by subtracting 0.821 from the value of pi. This gave us an approximate value of 2.32. We then multiplied this by 4 pi in order to solve for t. This gave us our third solution of 29.16 seconds. Again, we had to take this solution and add on the period in order to come up with our fourth and final solution of 108.12 seconds. For our general solutions, we took the two lowest values and added the period values onto them according to the rules for finding repetitions in the graph of a sine function. We used 10.32 seconds and 29.16 seconds to find the general solutions of 10.32 plus 8 pi squared times k seconds and 29.16 plus 8 pi squared times k seconds. These general solutions allow us to determine where further shooting opportunities may occur on the graph in case the producers of the movie want to include a longer chase scene. Luke is strategically moving up and down to evade Darth Vader. At the point 10.32, 0, or at 10.32 seconds, Luke is at the same height as Darth Vader and can shoot. At 19.74 seconds, Luke is at a maximum height of 1 foot above the x-axis. He shoots Vader again at 29.16 seconds. Then he goes to the minimum of 3 feet below the x-axis at 59.22 seconds. He arrives again to shoot Vader at 89.28 seconds. Finally, he goes up to the maximum, then down at 108.12 seconds to end Vader once and for all.